Alrighty, but let's get into it, guys. Right, so I'm not going to go through the details of number patterns again. We've done it. We know what number patterns are. We just now need to apply the knowledge that we already know. Okay, now guys, I know that number patterns as a section, a lot of us struggle with. And so that's why it's also important that we revise this section. But like I said, there are videos on number patterns. Go and rewatch them. They're there for that purpose. But like I said, we're going to go over a lot of the important concepts in today's lesson. So if you do feel a bit uncomfortable with number patterns, today is the day to hopefully feel more comfortable. All right, so a number pattern essentially shows a relationship between two values. So it is a description of a relationship between two values. Often we call these values variables. Now, importantly, we can use different variables to represent this relationship. Often we have what we call an input and an output value. Our input is represented by X or by N, depends if you use Tn and N. And we have an output variable, which is represented by Y, or if you're using the other notation, Tn. I don't mind whether you use X or Y or Tn and N. It's completely up to you. Your teacher would have probably told you which they prefer you use. Personally, it makes no difference to me. We do start to use Tn and N a lot more as you get to grade 10. So it's probably the one to start getting comfortable with. But at this point in grade 8, it really makes no difference. You're doing the same thing. All right. Now, what's also really important about number patterns is once we have the general relationship or the general rule or an understanding of what the relationship is between these two variables, we can start making predictions about the relationship. So for example, if we think of how this would be useful to us in the real world, if one day you own a business, right, and you start to plot a graph that predicts or that looks at the relationship between your income and expenditure, i.e. looking at the profit that your business is making, you would be able to plot a graph that shows how much profit you're making month to month, week to week, year to year, whatever you want to do. All right. And this is important for businesses because obviously they want to know whether or not they are going to be successful. And so if you can start to look at the relationship between your income and your costs, looking at your profit, you can start to predict whether or not your company or your business is going to be successful in the future. And so this is where the predictions and the ability to make these predictions comes into play. All right, so that's just one real world example. There are many. But us being able to see a relationship between variables and therefore describe their relationship, come up with a rule, allows us to make predictions about future trends in the relationship. Alrighty, so if we have a look at some examples of number patterns, we're going to start off quite easy and we'll build it up as we go along. Let's have a see of one type of number pattern that we can work with. All right, so here's our pattern that we have. We've got the pattern 3, 5, 7, 9, and 11. And all I want from you guys is two things. So the first thing I would like you to give me an answer to is a description of the pattern. So just use words. What is happening what is happening in this pattern, one output to the next output. And the second thing I want you guys to do for me is I want you to tell me what the next 3 terms in this number pattern are. So let's see if we can do that. I'm changing my second number pattern. We'll come to that in a second. Oh. Okay, so again, describe your pattern just in words, what's happening, and then the next 3 terms for me. Nice, guys. Okay, so the way I approach any number pattern question, it doesn't matter what it is. I don't even look at the question. I first start by asking myself, what's going on? So I would have a look at this number pattern and say, okay, cool. How am I going from 3 to 5? Well, I add 2. From 5 to 7, I add 2. From 7 to 9, I add 2. And what I see is that I'm consistently adding the same number. Now, cool. When we add or subtract the same value, this is called a linear pattern. So when we add or subtract the same value, we have a linear number pattern. Okay, now the reason I'm pointing this out to you is because you eventually, as you go up in maths, are going to start looking at different types of number patterns. Okay, we get lots of different types of number patterns. We deal with linear, quadratic, and geometric from grade 10 to grade 12. And so it's important that you start to identify the characteristics that make a pattern. So a linear pattern is when we add or subtract the same value each time. It can be any value. As long as I'm doing the same thing, adding the same thing, or subtracting the same thing from one term to the next, I've got a linear pattern. All right, so we've been asked to describe the pattern. There's lots of ways that you can get it across, but essentially we're adding to each time. So we add to the current term to get the next term. Right, now we're going to take a little tangent. I've now introduced a word here, term. Now these values that make up the pattern, these are our terms. Okay, these are also what we call our output values. And so, this is the y variable that I was referring to earlier when we talk about outputs. Okay, so the terms are your y values, or if you're using n and tn, sorry, I have to plug in my laptop, this would be your tn value. That therefore means that your x value is the position of your term. Okay, so the position of your term, first, second, third, fourth, fifth, those are your input values. So your x terms, or if you're using n, your n terms. All right, so it's just important that we know the difference between the two. So the actual value of the term, so the actual number pattern, those are your outputs, your y values or your tn values. The position of the term, so whether it's the first, the second, the third, the 27th, the 1 millionth, that is your x value or your input value. Okay, so our description is looking at how we get from one output value to the next. I just want to write that down. So a description, if I ask you for one, is how we get from one output value to the next. All right. Now, the reason it's important to differentiate that is because we're going to chat about rules just now, and those are different. So we've got a description, and as a lot of you have then correctly given me there in the chat, our next 3 terms, we just keep adding 2. So 11 plus 2 is 13. 13 plus 2 is 15. 15 plus 2 is 17. And so our next 3 terms, 13, 15, 17. Nice and easy. All right. What I haven't asked you here, which I am going to ask you here, is to give a rule for this pattern. So I'm just going to put it in here. Please don't fight me. We're all friends. Oy vey. Okay. Apparently we're not all friends. So another question I could ask you would be, give a rule to describe that pattern. Now, guys, a description and a rule are two different things. And we need to remember that as we start to do our patterns. So giving a rule, very different to describe. All right, we're going to do this one together because, like I said, it is different and we need to be mindful of that before we get our rule and our description mixed up. So if we just give a little definition for ourselves, a rule is different to a description. As I said, a rule is how we get from the input value to the output value. Oops. Right, so this is a bit different to a description. It's not going to be as simple as just add to. We essentially now need to ask ourselves, how do I go from our input values to our output values? So how am I going from 1 to 3, from 2 to 5, from 3 to 7, 4 to 9, etc., etc., etc. Now there's a little trick. There is a little trick that we can use. So whenever we want to give a rule, the coefficient to x or n depends on what you use. So the number in front of x or n will be what we're adding or subtracting. Right, so in this case, we're adding 2. So we will have y equals 2x. That will always be the coefficient, always. Okay, if it's a linear pattern, this will always happen. Now I just need to double check that I'm not necessary, or I don't need to maybe add or subtract something else. So we go back up to our pattern and we give this a try. So this is my first x value of 1. If I say 2 times 1, I get 2, but I want 3. So I'd have to add 1. Let's double check. 2, so I'm going to go up here. 2 times 2 gives me 4, but I want 5. So I need to add 1. If I go to my next input of 3, 2 times 3 is 6. I want 7, so I need to add 1. And so to my rule, I'm going to plus 1. And that is how we get a rule to describe our number pattern. So a rule and a description, two different things. And it's very important that we don't get them mixed up. Right, all I'm writing here is if you use Tn and n, it would be Tn equals 2n plus 1. Means exactly the same thing, which is why I'm saying I don't particularly mind which you choose to use. But a description and a rule are two different things, and we need to make sure we don't get them mixed up. Okay, so I know this is a lot of information. I'm going to give you a second to take a screenshot, take down what you need to take down, as well as if anyone has any questions, you can raise your hand and ask. Otherwise, we're going to try another one where we're going to answer these exact same 3 questions. And that's why a screenshot is useful, so you can go back and see what was going on. I will actually also make it smaller so that you've got all of this on the screen as well. Oh, sorry guys, what's going on in my eye? Okay, so any questions, feel free to raise your hand, or remember you put them in the chat, and between Yolanda and myself, we will help you. Okay. Right, so you're going to answer exactly the same 3 questions, and I'm just going to make it smaller so you've got what you had there. But now for the pattern that I've given you here in question B. So next 3 terms, and then give. So here is your pattern. Your pattern is 4, 1, -2, -5. So remember, like I said, first thing we always do is don't stress about the questions just yet. Figure out what is happening to get from one term to the next. And then you can go ahead and describe the pattern, give me the next 3 terms, and then give me a rule for this number pattern. So in the chat, that's what I want to see happening. Let's give it a go. And then we'll have a look at the answers in a few minutes. So I want a description. I want the next 3 terms. And then I want the rule for this number pattern. I've left question 1 up, so you can see how we did essentially all of those questions in the previous example, and that will help you get your answers to the second example. You guys remember, put your answers in the chat as you get them. So once you know what's going on, put your description in, and then your 3 terms, and then your rule. Now remember, your rule is not the same as your description. So your rule should not just be x minus 3 or -3. Your rule should be y equals and then something happening to x. So look at what we did in question 1 and see how you can now apply that to the second example. All right, and guys, just remember that these are your output values. Your input values are their positions. So the first, the second, the third, the fourth, etc., etc. Right, I'm going to give you another minute. Okay. Right, guys, so let's have a look. So like I said, the first thing I always do is I don't even look at the questions. I just look to see what's actually happening in my pattern. All right, so that's what I'm going to do. If I go from 4 to 1, I'm subtracting 3. So essentially what we want to see is, does that remain true for the rest? well, 1 minus 3 is -2, so that's true. And -2 minus 3 is -5. So this is true. This, because I'm subtracting the same value each time, means it is linear. But now I know exactly what's happening in my pattern. This also means that I'm now able to answer the question of describe the pattern. All right, know what's happening, I can now describe it. So we subtract, what else? I'll subtract for a second. 3 from the current term to get the next term. Obviously, yours doesn't have to be word for word what I've just written down. As long as you've gotten across that you're subtracting 3 each time, we're good. All right, the next question is then asking us to give the next 3 terms. Okay, not too tricky. We can all do that. Because we now know what the pattern is, it's nice and easy for us to give the next 3 terms. So we're currently at -5. We need to subtract another 3, which gives us -8. Subtract another 3, which gives us -11. Subtract another 3 gives us -14. So we are able to get our next 3 terms just because we know what the pattern is. Right, this last one, guys, we now need to actually go and give a rule for this pattern. Now remember, a rule is not the same as a description. A rule means that we need to have y equals. Now the trick, remember, y equals whatever we are adding or subtracting is our coefficient to x. So we're going to have -3x. Now we want to double check, is there anything I need to add or subtract to that product to make sure I get my output? So just for sake of things being a little bit easier for me to have them right here, I'm just going to rewrite our pattern. 4, 1, -2, -5, and this was the first, the second, the third, the fourth. Okay, so we have already established that we are going to take this 1 and times it by -3. Now 1 times -3 gives us -3. We want +4. So I have to add 7 to that. Let's just double check if that remains the same or remains true here. So 2 times -3 gives us -6, but we want a value of +1. That means I'm going to have to add 7. And so my rule now for this number pattern is y is equal to -3x plus 7. Right? We can double check with the next one if we're not entirely sure. +3 times -3 is -9. -9 plus 7, -2. So we can always keep checking if we're not 100% sure. But our rule here is exactly that. If you're going to use Tn, Tn is equal to -3n plus 7. Don't mind which one you use, completely up to you. They both mean exactly the same thing. Okay, so guys, even if we are subtracting values, as long as it's the same value each time, nothing changes. We can follow exactly the same steps as what we did before. Okay, so Lundeka, I got the -3 because if we go back up to the top here, I can see that I'm subtracting 3 each time. And so because I know that I'm subtracting 3 each time, that becomes my coefficient to x. So remember I said up here at the top that the coefficient to x will be whatever we add or subtract. And so because I was subtracting 3 each time, that became my coefficient to x. Okay, so that's where the -3 came from. Ziva, Tn means term number. So term number 3 has a value of, in this pattern, -2. So for example, if we look at that situation over there, we could say term number 3 has a value of -2. Term number 4 has a value of -5. So Tn is the value of any term in the pattern. Oops. Okay, because now that we've got a rule, we can technically find any term. Because now if I said, what would the 100th term in this pattern be? We know that X represents the position. So I could just substitute in 100 there, and I could find out what the 100th term in the number pattern would be. So Tn is basically just a term or any term in our number pattern. Alrighty, guys. So let's take our screenshots. If we have any further questions, obviously feel free to raise your hand and ask. Otherwise, it's been a lot of information, so we're going to take a little break before we carry on with our next example. Again, any questions, feel free to raise your hand. Otherwise, again, keep putting them in the chat for me. And guys, remember, like I said, we have done this, so if you do need a little refresh on number patterns, feel free to go and rewatch the videos if you need. Okay, good. Right, brain break time. I hope you appreciate my joke because I'm obsessed with cows. And so a good cow math joke is always great for me. But obviously, you know how this works, guys. We want, or I want, the value of the very last equation here. So the first person to get it right will explain it for us. We look forward to seeing who that will be. But I hope you enjoy the calculator joke. But otherwise, let's give the brain break a try. I just want to pop my lights on, so I'll be too. All right, remember, I'm on the lookout for the first person to get it right. Let's see how we go. Very quiet today, great. Eights. All enjoying our first proper day of holiday. Nice, Busisiwe, first one. Well done. That was very quick. I'm very impressed. Busisiwe, if you want to raise your hand and you can explain to us how we got, or how you got 292 as your answer, that'd be amazing. Okay.
Hi, ma'am.
Hi, Busisiwe, how are you?
I'm good, and you, ma'am?
I'm all right, thank you. Okay, how did we get this?
So for the first one, I first said 54 divided by 3, and I got 18.
Nice.
Then I said 18 divided by 3, and I got 6.
Why by 3?
Because there were 3 ice cream cones. So then when I got the 6, I said 6 times 2, which is 18, and I added all of them as 18 to get 54.
Okay, just careful. 6 times 2 is? 12.
Oh,
But
12.
9 times 2 is 18.
18.
So 1 ice cream cone is 9.
9. And then for the second one, I said 9 times 9 plus 8 to get 89.
Perfect.
For the third one, I said 16 times 16 plus 8 to get 264.
And where did the 16s come from?
The 16 came from the previous cake that was 8. So I multiplied the 8 by 2.
Perfect. Excellent. Well done. Okay.
And then the last one, I said 4 plus 18 times 16 equals 292.
Excellent. Well done. Okay, so guys, really importantly, they're exactly what Busisiwe did. We need to be very careful where there's doubles and where there's singles. And that's why I asked where the 16 came from in the third equation, because we need to know that if there's 2 cakes, we have to double what it was. Nice, Busisiwe. Thank you very much. Well done.
Thank you, ma'am.
All right, guys, and remember, obviously, we always need to apply BODMAS, so the times always need to happen first, as Busisiwe did. So always just remember that when doing these situations. I just want to go back to this first one because I think maybe I was also having a bit of a holiday brain moment. Because you actually have 6 ice creams in total here, if you had said 54 divided by 6, you would have gotten 9. And so then you would know that each of these ice creams is 9 individually, and so 2 makes up 18. That's absolutely fine as well. Right, so lots, like a couple different ways that you can do the same thing. But either way, 2 ice creams is indeed 9. I'm glad we're enjoying the joke. Like I said, I'm obsessed with cows. So any joke with a cow, and particularly a maths joke with a cow, loved. Alrighty, guys. Let us do 1 or 2 more. You guys are doing amazingly well. Right, so what I want you to have a look at here is question C. Now, for question C, we're going to answer the same 3 questions. So give the rule. But what I want you to take careful note of is that we aren't necessarily always adding or subtracting the same number, right? So sometimes our pattern that we are given isn't necessarily a linear pattern. Now that's fine. Like there's nothing wrong with me not giving you a linear pattern. That's okay. But we need to just bear it in mind that we don't always get linear patterns. Okay, so I've given you a big hint here. All I want from you guys right now is to try and just, we've used pink already. Okay, let's go green. All I want you to try is to describe the pattern. Okay, if you feel really confident that you can answer the next 2, that's actually, you can answer the next 2. So all I want from you is to describe the pattern and give me the next 3 terms. Because if you know what the pattern is, then you can give the next 3 terms. So I want you to try those first 2 questions for me. Let's see what we get. And then we'll chat about what the rule would be. If you can do the rule, then that's amazing. You can keep going. But what I want to start off with is an answer to the description and then the next 3 terms. Umfa, I'm so sorry that you've lost your calculator. That's never fun. You definitely do need to try and replace it, but you know that. But well done on giving it a try in any case. Oh, it would help if I showed the pattern here. Right. So there's your pattern, 1, 8, 27, 64. Let's describe it and let's give me the next 3 terms, please. Zandile, I will go back to question B just now once we've done this one and you can take a screenshot of it. I'll go back. Okay, so I want description of the pattern and the next 3 terms. If you can do the rule, that's awesome. Please do it. Otherwise, we will have a look at the rule together in a second or two. And then Zandile, like I say, and for anyone else, if you didn't get a screenshot of question B, I will go back in a second and you can take a screenshot. Well, guys, your descriptions are so good sometimes. Like, they're even better than what I would do. Like, it's really impressive. Well done. Come and give me another minute to answer those first 2. Try the third one. I know you can do it, but if you're feeling a bit stuck, we will go through it together. You guys have seen the pattern really nicely so far. And remember, guys, when it comes to patterns, that's exactly what we want to see. If it just looks like a random mess, there's no pattern that's going to help us. So we always want to try and get to what is the pattern, what am I doing to get these output values? Okay, 1 more minute. Hey guys, let's have a see. All right, so like I said, first thing I always try and do is I try and see what's going on with this pattern. So if we go, and I see some of you have put it in the chat, if we now go and ask ourselves, okay, well, oh God, how am I getting from 1 to 8? Well, there's lots of ways we can get from 1 to 8. We could say 1 times 8. We can say plus 7. But if we go with the addition idea, if we want to go from 8 to 27, we would have to add 19. So that's already not the same value. If I want to go from 27 to 64, I have to add 30 something. Maths. 37. Okay, so those aren't the same, which means this definitely is not a linear pattern. These aren't even consecutive odd numbers, because from 17 to 19, that's adding 12. And then from 19 to 37, we are adding 18. So that's not even helpful to us, right? If I go back and I say, okay, well, if I say 1 times 8, that's not consistent, because I'm not saying 8 times 8 to get 27. So I'm a little bit stuck. So now I need to go back to the original question. How do I go from input value to output value? And a lot of you saw the pattern. If we take our input values and we cube them, we're getting the output values, right? So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So what we are doing in terms of the description of this pattern, we cube the input value to get the output. Okay, that does mean that our rule becomes a lot easier to find, but we now know what we're doing. It's easy enough to deal with. So when we now have to give the next three terms, that also is a lot easier. We've got the first four. We now need to find what 5 cubed is, so 125. What 6 cubed is, 216. And then what 7 cubed is, 343. And so our next three terms are 125, 216, 343. So like I say, once we know what's going on in our pattern, the rest of the questions become a whole lot easier to answer. All right. If we now want to give a rule for this pattern, and like I say, because we've got the description, it is a little easier to do. We've already said that we're taking our output value. No, in order to get our output value, we are taking our input value and we are cubing it. And so our rule here is quite simply y is equal to x cubed. So guys, really importantly, not every pattern will be adding or subtracting the same value each time. These, so cube patterns or cube numbers as well as squares, we love to ask, right? So just because it's not the linear pattern does not mean we can't ask it. And like I say, as like a challenge question or a question we like to give you to make you think a little bit, cubes and squares. So in the back of your mind, when you do number patterns, you need to think of cubes and squares because we do like to ask them quite a lot. All right, so because it was a question to screenshot B as well, I'm just going to make that a touch smaller. You can screenshot both B and C if you still need that. And then we're going to have a look at one more before we end off. So many colors. I love colors. This makes the whole thing a little bit nicer. All right, guys, any questions while you're taking screenshots? Please remember, you can put them in the chat, but you can also raise your hand at this point if you do have questions. You guys are doing really nicely, though. Right, so the next sort of type or way that we can give you a number pattern type question is through a picture. All right, I hope we've all got this. So we often need to deal with number patterns in terms of a picture. So we are going to look at, let's look at this one. Okay, with some matchsticks. So here is our picture or our number pattern, but represented with pictures. We've got some questions we want to answer. I don't care about those questions right now. What I want you to tell me to start off with, and let's maybe not have a weird glittery aqua pen going on here, is how many matchsticks are in each picture. So I'm saying each picture, they say terms, but this would be picture 1, picture 2, picture 3. You can call it term 1, term 2, term 3. It honestly makes no difference. That is the first question I want you to answer. So ignore the other 3 questions. I want you to tell me to start off with how many matchsticks are in each picture that I've given you. Obviously, I need to give you a second to just count. So have a think, have a see, and let's see what we get. Nope, sorry, bro. Okay, I'm going to give you 1 more minute to count. If you know how many are in each picture, see if you can figure out what the pattern is. Right, nice, grade 8s. Okay, so in picture 1, we've got 12 matchsticks. In picture 2, we've got 19. And in picture 3, we've got 26. Okay, so that therefore means that we can figure out our pattern quite nice and easily. We are adding 7 every single time in order to get the new image. So that means that when we are asked this next question, how many matchsticks will be in the 4th term or in the 4th picture, that's quite nice and easy. So everyone on the chat, how many will there be in the 4th picture? I've seen a whole 4 answers. Okay, let's keep going. So remember, we're adding 7. Nice, guys. So we take the last one that we have, we add 7 matchsticks, and we get that there will be 33 matchsticks in picture 4. All right, so I want you guys to try all by yourselves this next question for me. So I want you to try and write down a rule for this pattern. Okay, so we've done it a few times. Let's see what you guys can come up with here. Write down a rule for this pattern. So remember, it'll be y equals or tn equals, and then your rule. It is not as simple as just plus 7. Okay, so let's try our rule. And remember, I've given you a hint of how you can start this rule. If you're not sure, go back to your screenshots and have a look at what we wrote down or what we did each time. And guys, that's a really important skill to learn and master, is that if you don't know how to do something, go back to your notes. You've been doing it, whether it's in class, whether it's with Watobe, whether it's through studying by yourself, you know how to do it. If you're feeling a bit stuck, go back to your notes. Okay, so remember, guys, I'm not asking you to describe the pattern. I'm asking you to give the rule. So description would be in words, what are you doing from one output to the next? I want a rule. So y equals something happening to x plus or minus something, or tn, and then same sort of thing. Okay, so we automatically know that it has to be 7x. Remember, I said to you, whatever you add or subtract, that becomes your coefficient to x. So now we go and double check. If I take 1 and I say 7 times 1, that gives me 7. But I don't want 7. I want my output of 12. So to get from 7 to 12, I add 5. Let's double check. Here's 2. 2 times 7 gives me 14. I don't want 14. I want 19. So if I add 5, that gives me 19. So my rule here is going to be 7x plus 5, or Tn is equal to 7n plus 5. Again, I don't mind what you use. It's up to you and what you've been told to do, but that's our rule. Now we can double check. So if we take 7 times 3, we get 21. 21 plus 5, 26. 4 times 7, 28. 28 plus 5, 33. And so because I'm always getting the correct output according to my rule, I know that the rule that I have given here, or the rule that I'm working with, is correct. All right. So guys, just to end off, if we have a look at this last question, and I love questions like this, love number patterns. I am asking you which term or which image will have 110 matchsticks. So if I keep this pattern going, at what point will I eventually draw 110 matchsticks? Now remember, if we go back to this whole table, this Y value is your number of matchsticks. Okay, so we've given you, or I have given you, a Y value here. And because you have an equation, all you need to do is you need to sub in for what you know, and you need to solve for your unknown. So we're going to solve for X. So that means I'm going to subtract 5 on both sides, giving me 105 equals 7x, because 110 minus 5 is 105. And then we know that because we're solving for x, I'm just going to carry on up here because I haven't got enough space. We are going to divide both sides by 7 because I want x. Now 105 divided by 7, as a lot of you have already put it there on the chat, is 15. So if I carry on drawing this pattern to the 15th picture, I will be drawing 110 little lines. And this is where that prediction idea comes in. I can make a prediction, or I can start to get more information about my pattern the second I start finding rules and relationships.